Homework solution 6.2. Write Kirchhoff's voltage law for both the primary and secondaries in the following transformer circuits, paying attention to the indicated current directions. So you can see here that there are current arrows here. So what we're demonstrating in this problem is the dot convention. So remember that the dot convention says that when current enters the dotted terminal of the primary, being a little finicky there. When current enters the dotted terminal of the primary, as is demonstrated in these two, so current's entering the dotted terminal of the primary, the voltage at the dotted terminal of the secondary is going to be positive. So the corollary to that is if current leaves the dotted terminal of the primary, so that's illustrated by B and D here, the voltage at the dotted terminal of the secondary is negative. So that's the dot convention that you should remember. And so I'm not going to write givens and stuff like that because it's all graphical here. So I'm just going to go straight to the solution. This is more about keeping track of polarities and transformer circuits. So I'm just going to write the KVL for the primary. I can see that V1 here is, I'm going to define it as positive in that direction. And so to write KVL, I've got V1 plus the voltage drop across this resistor plus the voltage drop across the primary coil is going to be equal to 0. So voltage summed around a closed loop is 0, so that's V1. And then I can see that I1 is flowing into this resistor, so that's positive there and minus there in terms of the voltage drop across that resistor, so that's minus VR1. And then again, I've defined the polarity of the voltage across the primary as positive as to where the current enters the terminal there. That's the convention for a transformer, so that's going to be minus VP is equal to 0. So I would probably rewrite that as V1 equals I1R1 for the voltage drop across that resistor plus VP. So that's the KVL for the primary side. So now we need to go over to the secondary side. We saw that current entered the dotted terminal of this transformer, and so therefore the voltage on the secondary is going to be positive at the dotted terminal of the secondary. So that's going to give me that right there. And then I'll put my plus minus sign there for V2. So now I just need to go around this loop right here, and I can see that I've got Vs here. I need to determine what the polarity of the voltage drop across R2 is, and remember current enters the positive terminal, so it's going to look like that for VR2 right there. So now I've got all the polarities, I can sum them. I can say that voltage rise, Vs, plus another voltage rise, VR2, and then I got a voltage drop minus V2 right there, equals 0. So probably I would rewrite that. I would say that V2, the voltage here, is going to be equal to the secondary voltage plus I2 R2. And I've already taken into account the current direction there because of these polarity symbols right there. So that was the solution for A. V1 equals I1 R1 plus VP, and V2 equals VS plus I2 R2. So moving on to B, we see that the layout is similar, except now current is going to be leaving the dotted terminal. So you'll notice that I1 is defined in the same direction. That means that's plus, that's minus, the same here, plus and minus, such as that. So again, we're using the primary side to set those reference directions. So in B, we can see that the KVL for the primary side has not changed at all. We get V1 equals I1 R1 plus V peak. So no new work needs to be done there. So what we do have to do is figure out the reference direction for the secondary voltage in this transformer. Current is leaving the dotted terminal on the primary. That means the voltage that's induced in the secondary is going to be negative at the dotted terminal over here. So I get a plus and I get a minus right there for Vs, we notice that I2 has been defined for us as flowing into this transformer. That means this secondary looks exactly like this secondary. These are, in essence, the same circuit. So this is also V2 equals I2 R2 plus VS. I've switched the order here, but right, those are the same problem. So that's B. C, we come over here and we draw our polarity markings for V1. We've got current entering the positive terminal of this resistor, so that's VR1 there, right there. We've got the same current directions, VR2 right there. So now our task is, what is the polarity of the secondary voltage here? So here, current is entering the dotted terminal of the transformer. That will induce a voltage that is positive at the dotted terminal of the secondary. So that is indicating that the polarity in the secondary voltage is as I've just drawn it. So there is plus minus Vs. So now what I need to do is write KVL for both sides. I can see that this circuit hasn't changed at all, so that's still V1 equals I1 R1 plus VP on that primary side. If I look at the secondary side, I just need to go around the loop. Oops, I forgot to label those. Just need to go around the loop here, and so I've got a voltage drop, that's negative, minus Vs. I've got a voltage rise, that's positive, plus VR2. And then I've got a voltage drop, that's negative, minus V2 is equal to 0. So I can rewrite that, and I could say that V2 is equal to VR2, or VR2 minus Vs. And that would also be V2 is equal to I2 R2 minus Vs. So we can see this is swapped the polarity right there of Vs. So in part D, I think we've done enough examples. We see that part D, the primary hasn't changed again, so it's V1 equals I1 R1 plus VP, so that doesn't change. What we now need to do is just keep track of what the polarity of the secondary voltage is going to be over here. Again, current's leaving the dotted terminal, so it's going to induce a voltage that is negative at the dotted terminal of the secondary. So that's going to look like this, plus minus Vs right there. We've got plus minus V2, and that means V2 is, well, this circuit's the same as this circuit, so V2 is going to be equal to I2 R2 minus Vs. So these are the possible permutations of the current directions and polarity symbols, or the dot symbols, the dot markings of ideal transformers, so that you now know how to apply those in all possible situations.